The simplex algorithm is an algorithm that we can use to solve a linear program. This allows us to extend our problems, linear programming problems, to more than just 2 dimensions. So in the previous topic, we looked at solving graphical linear problems, and we did that by plotting our 2 variables, x and y, plotting a load of constraints, like so, and creating for ourselves a feasible region from which the x and y can lie. Now, graphically, we can solve linear programming problems in 2 dimensions using this method that we've previously looked at. We can also use 3 dimensions, but of course the graph would be a 3-dimensional graph, and the feasible region would now be some kind of volume as opposed to an area. So that's quite complicated to do, but then there's no way then to solve a linear programming problem with more than 3 variables graphically. So we look to the simplex algorithm, which allows us to solve linear programs with more than 3 dimensions. Okay. There are 2 requirements for the simplex algorithm to work. Those requirements are: the origin must be feasible, so it has to be one of the vertices of the feasible region. And the second one is all variables are non-negative at all times. Okay, you can't have negative variables. Okay. So what I'm going to do is, in this video, I'm going to set up the problem and how we start going about solving a linear program using the simplex method. And then in the next video, I'll actually carry out the simplex method, okay, to show you. So the simplex algorithm uses what's called tableaus, or tables, if you like, a series of tables to go from one iteration to the next. So what we're going to do in this video is set up the initial tableau. Where do we start? So here we have a linear programming problem. This is one you can solve graphically, and in the next video I will be solving this very linear program using the simplex method, and I can then refer to the graph as we go through this problem. Okay. But what we're going to do in this video is just take this problem and get the initial tableau. So I've got this constraint down here: x and y must be positive, or sorry, non-negative. So this has to be true anyway. So this doesn't actually have any bearing on the linear program for the simplex method. Okay, so it has to be true anyway, so I can actually ignore that one. Okay. Now these 3 constraints, what I'm going to do is I'm going to change them from inequalities into equations, and we're going to look at how we do that shortly. And then we have already an equation up here. Okay. That's my objective. Okay, so let's take this first inequality, x plus y is equal to is less than or equal to 21, and I'm going to say x plus y, and then I'm going to introduce a new variable, which I'm going to call s subscript 1, and then I'm going to replace it with an equal sign. And 21. Okay, so this inequality, less than or equal to, has now been changed to an equation with an equals, and to take up the difference between what x plus y is and the number 21, I've introduced this new variable. Now this new variable s1 is referred to as a slack variable. It is a variable in terms of the simplex method, so the algorithm will recognize this as a variable just like x and y. Okay, it's not going to be able to differentiate between x, y, and s1 as you go through the algorithm, but it represents something different. We'll get onto that, what it represents, when we solve the problem in the next video. Okay, but whatever x and y equal, it has to be less than or equal to 21, and then the slack variable s1 will take up the shortfall. So for example, if x plus y is 10, then that means s1 will be the number 11, so that this equation is true. And of course, x plus y is less than 21 because that was the number 10. Okay, so it's a way of changing an inequality into an equation. Okay, so introducing an extra variable. Okay, and then we repeat that same process for the other 2 constraints. Okay, so we've got this constraint here. So this constraint is going to become 3x plus 5y plus a different slack variable. So I'm going to denote this one s subscript 2. And then that's going to equal 75. And then finally, this third one, again, let's take the inequality x plus 8y plus yet another slack variable, and that's going to equal 82. Okay, so we've changed our three inequalities into equations. Don't need to do anything with these two inequalities because that has to be true anyway, so I can ignore that. And the only thing left to do is look at the objective, and the objective is fairly straightforward. I just need to put all the variables on one side for the simplex algorithm. Okay, so you notice here that all the variables are on the left, and I've got then the right-hand side are just numbers. I'm going to do the same thing with the objective line. So I end up with p minus x minus 2y, and then I'll be left with no numbers. So that's going to equal 0. Okay. All right. So these three represent the constraints, now written as equations, and this one is the objective. Okay. Now what we can do is we can take those four equations and we can write them in a tableau, and this is our initial tableau. Okay. So our initial tableau looks like this, currently empty. We're going to fill the numbers in, and each row is going to represent an equation. Okay, so we've got four equations, we've got the three constraints plus the objective, and we've got four rows here. The top row, I've put a double line here just to emphasize that this row is different to these three, because that row is where the objective is going to go. These three are where the constraints are going to go. So the objective row, p minus x minus 2y equals 0. So this table is just going to represent the coefficients of that. So I'm going to have 1p, I'm going to have minus 1x, I've got minus 2y, I've got no slack 1, no slack 2, and no slack 3, and the right-hand side is 0. Okay, there we go. That's the first line of my initial tableau. Okay, now I do the same thing for these three. So we've got x plus y plus s1. So I've got 1x plus 1y plus 1s1. There's nothing else on the left-hand side, so no other variables. So there's no p, no s2, and no s3. And then the right-hand side is the number, which is the number 21. Okay. Next constraint, 3x, 5y, and an s2. So that's 3x, 5y, and 1s2. No p, no s1, no s3, and that equals 75. So the right-hand side is 75. And then finally, the fourth constraint, we've got 1x, 8y, and an s3. So 1x, 8y, no s2, no s1, and 1s3, and that equals 82. And there's no p either. And that is the initial tableau for this linear program ready for simplex to be carried out. Okay. All right, so let's have a look at a similar problem, but this time we're going to look at one which has got three variables. So this time I've omitted the x and y are bigger than or equal to 0, but you should have that in your head at all times. So we've got four constraints this time, so we're going to have four constraint rows. We're also going to have one objective row again, but because we've got four constraints, we're also going to have four slack variables. Okay, so this top one is going to become 2x plus y plus a slack equals 40. Okay, so the less than or equal to has been replaced with a plus s1 equals, just like it was in the previous example. The next one, we've got 2y plus 3z plus another slack is equal to 48. This one, we've got a z plus another slack is equal to 10. And then this one here, we've got an x plus a 2y plus a 3z plus another slack, and that's going to equal 30. So those are my four constraints. My objective, well, I'm just going to bring these x, y, and z across to the other side. So I get p minus x minus y minus z equals 0. Okay, so those are my 5 rows of my tableau. And here's my tableau. This time it's a bit bigger because I've got an extra row for the fourth constraint. I've also got an extra column for my third variable, z, and I've got also an extra column here for my fourth slack variable as well. Okay, so it is a bigger table. Okay, So top row is going to be the objective row. So 1p minus an x minus a y minus a z, no slacks, and that equals 0. And then each of these are going to have their own row. So the next row is going to be this constraint, which is no p, 2x, 1y, no z, 1s1, no s2, 3 or 4, and then it's going to have 40 on the right hand side. And the next one is we've got 2y, 3z, a slack 2, no slack 3 or 4, and a 48. The next one, we've got 1z and an s3, and then on the right hand side we've got the number 10. Everything else is 0. And then finally, I'm not quite going to have space to put both the row and the equation on the board, but 1x, 2y and a 3z and a slack 4. Okay, so 1x, 2y, 3z and a slack 4, nothing else. And the right hand side was the number 30. Okay, so there's my initial tableau. Again, that is ready then for Simplex to be carried out. Before I finish this video, there's a few definitions that I want to say what they are. I'll be using throughout these Simplex Algorithm video series. There's different names that are given to the variables. So these three, x, y, and z. Okay, x, y, and z. In this case, or the previous example was just x and y. These are referred to as the objective variables. These four, as we've already mentioned, are referred to as the slack variables. And then this one here, P, is referred to as the objective. Oh, sorry, that should be decision variables. Decision variables, and that's the objective variable. So I'll repeat that one more time, so I made a mistake there. X, Y, and Z are referred to as the decision variables. S1 to 4 are referred to as the slack variables, and P is referred to as the objective variables. These hold true for the whole program. So every iteration of Simplex method, those definitions will hold. S1 to 4 will always be slack, X, Y, and Z will always be decision, and P will always be an objective. Okay. There are two other types of variables which they can be classified into, which are referred to as the basic variables and the non-basic variables. And these change as you go from iteration to iteration. So just be aware of these. I'll define them in the next video when I actually carry out the Simplex algorithm. But these change from iteration to iteration. Okay, as we move around the Simplex, the basic and non-basic will shift around. Okay. Okay, so that's all I want to do for this video. Check out my next video where I'll be solving this linear program using the Simplex method, and I'll be referring to the graph as we go. Thank you very much for watching.